All right, in this video, I'm going to go over everything you need to know about rational functions in our algebra class. We broke it up into these three standards. There's this use functions to represent situations. Those are all the word problems. There's graphing rational functions and doing algebra with rational functions. And so I'll do a problem at the level 2, the easiest level, and then kind of the medium level, and then the hardest level. I'm not going to do each and every problem because that would be a 30 or 45-minute long video. But if you need more examples of anything, please let me know. I'm happy to go over more. So let's start with graphing. I'll go with a level 2 question, kind of looks like this. And then we'll go down to a level 3 question where x is on the top and on the bottom. And then we'll come on down here to a level 4 question where you've got x squared on the top and x on the bottom. Okay, so you can kind of see the progression there. So your basic one, 6 over x minus 5. I know that that means there's going to be a vertical asymptote at 5 because if x equals 5, that makes the denominator, the bottom, equal 0. I know that if I plug in x equals 0, then I'm going to have 6 over 0 minus 5, which is negative 5. That means my y-intercept is just a little bit below negative 1. 6 over negative 5 is negative 1 point something. Okay? If I plug in a number that's bigger than 5, then I'm going to have a positive answer. So if I plugged in like 10 or a million or a billion, this is going to be a positive number on the function. So I know that this side here is in the positive direction on the right side of 5. And similarly, if I plug in a number left of 5, I'm going to get a negative answer. I know if I plug in big numbers, my fraction gets really close to 0. Like if I plug in a million, I have 6 divided by a million. That's really close to 0. So that's why my function flattens out like this. The horizontal asymptote, right here that I'm drawing with this dashed line, the horizontal asymptote is y equals 0. And then the function on the left side also approaches 0, but it just approaches it on the bottom of the x-axis because it's a negative value. Okay, so I identified here's my vertical asymptote, here's my horizontal asymptote, here's my y-intercept, and there is no x-intercept on this one because my function never equals 0 as a y value. Okay, so keep that one in mind. I'm going to move on down to slightly harder version. Okay, the formatting here got a little funky, but this right here is a fraction x minus 7 on top, x plus 3 on the bottom. Okay, first things first, let's do that vertical asymptote. What makes the bottom equal 0? If I make x equal negative 3, then the denominator equals 0. That's a vertical asymptote. So this line that I'm drawing is my vertical asymptote. If I make the numerator equal 0, I get x equals 7. That's an x-intercept. Because if I plugged in 7, I'd have 0 divided by 10. Well, you know 0 divided by 10. 0 divided by 10 is just 0. So I can put a dot right there that when I plugged in 7 for x, I got an answer of 0 for y. If I plug in 0, I get 0 minus 7 over 0 plus 3. That's negative 7/3. It's a little bit more than negative 2. So I'm going to put a dot right there. That's my y-intercept, 0 comma negative 7/3. Now the horizontal asymptote. Let's plug in really big numbers. Let's say I plug in 1 million. The top is almost 1 million and the bottom is almost 1 million. If I plug in 1 million, I have 999,993 on the top because I did 1 million minus 7. And on the bottom, I have 1,000,003. Those two numbers are pretty much equal. They're almost exactly, when you divide them, equal to 1. And the more big numbers that I plug in, the closer that those two top and bottom get. And so then I will get answers that get closer and closer to 1. Same idea when I plug in negatives. So I can say that my horizontal asymptote is at y equals 1. Some people like the shortcut of just looking at the ratio of the leading terms. The leading terms are x and x, and if you did x divided by x, you get 1. So what that means is I have to hit my 2 dots there, flattening out at y equals 1. And then I mirror that shape up here. And of course, you can check your answer by looking at a graphing calculator. So that's level 2, or level 3, excuse me. A little bit harder. Now we're going to go on down to level 4, where it gets even harder still. So on this one, we've got a quadratic on top of a linear. We can do exactly the same process though. If we have x squared plus x minus 12 and x plus 1, let's start just like we did on the other ones. If I make x equal -1, the bottom is equal to 0. That's a vertical asymptote. Pop it in here. If I make the top equal 0, I know there's going to be 2 answers because it's a quadratic. Think of 2 numbers that multiply to make 12 and add to make 1. So I can go x times x. 12 could be 4 times 3. And if I make it positive 4 and negative 3, I'm going to multiply to make negative 12. See how this is 4 times negative 3? And I can add to make 1x. This is 4 plus negative 3. So now because I have it factored, I can see that there's 2 different x-intercepts. When x is -4 or when x is positive 3, then my graph is going to equal 0. My y value is going to equal 0. So I can put those dots in there. If I plug in 0 for x, I end up getting -12 over 1, the ratio of the constants. So -12 would be right down here. I can't quite fit it on my graph. The last thing I need to figure out is what's going on if I have a horizontal asymptote or a slant asymptote here. And if I plug in big numbers, the top gets squared and then the bottom stays linear. So the top is much, much, much bigger than the bottom. Like imagine 1,000,000 squared over 1,000,000 is a really big number. And so I know that my function is getting really big when I go to the right, and it's also getting really big when I go to the left. So it doesn't have a horizontal asymptote where it balances out. If I do just a couple steps of long division, so I know that like x times x makes x squared, x times 1 makes x, and I can subtract that away. See there? Those all cancel out, and I get 0 minus 12. There's nothing that I can multiply x by to make it turn into minus 12, so that's my remainder. What this means is my original equation can be rewritten as just the number x, and then it can be minus 12 over x plus 1. Okay? And that shows me what my slant asymptote is going to be. If I look at 12 over x plus 1, this part approaches 0 when I plug in big numbers. 12 divided by 1,000,000 is almost 0. 12 divided by 1,000,000,000 is so close to 0 you can ignore it. So this part right here is my slant asymptote. So y equals x is just this 45-degree line through the origin, and then my graph is just putting all those pieces together. So here's my y-intercept, vertical asymptote, slant asymptote. Same idea on the other side, vertical asymptote, slant asymptote, and that right there makes my graph. Okay, so in a separate video, I'll go over the other standard of solving, level 2, level 3, level 4, and then the word problems modeling. All right, please let me know if you got questions.